Okay. Yes. Good morning, friends. Welcome to the session once again. Okay. Good morning, friends. Welcome to the session once again. Today, as you know, we are going to conduct part 4, session 4, part 4 of Oceanography. Okay. We have already covered 3 parts, part 1, part 2, part 3. Today, we are going to cover part 4. Okay. Today is the session 4. Good morning once again to all my friends. Welcome to the session. In the middle of discussion, suppose if you are not able to follow any points, you can interrupt me at any time. You can do so by in the live chat box below. Okay, you can interrupt me at any point of time. Clear? If you have any doubt regarding any point that we have discussing regarding the oceanography, right from the ocean bottom topography, if you have any doubt on any sections, you can raise the question in the live chat box below. Clear? Now let me tell you at the outset itself. Here in this YouTube session, we won't be able to cover everything in detail because of paucity of time and also the ease of communication among ourselves. Okay? Why? Because we have limitations here. The only way to communicate between us is the live chat box below. Okay? Therefore, I have my course in Unacademy platform. There we have a lot of different tools like raise your hand. I can use many different tools in order to let you understand. We have sufficient amount of time there, so you can always, if you want to learn something in detail, then I have a course in Unacademy platform. You can always come and join me there. Clear? Anyways, let us continue our discussion today. But before going into that, let me give you some information from the Unacademy platform. As I've been telling you always, in Unacademy platform, programs or different courses get launched depending on the requirement of the exam and the upcoming exam. Now, one of the best example is last year, Unacademy launched this last mile program. Now, the success of this program is such that around 7 of them was there in all Indian rank 1 to 20. Around 20 learners from this particular program were there in this all Indian rank 21 to 100. Around 143 between all Indian rank 101 to 761. If you also want to see yourself in this successful list of candidates, you can always subscribe for the Unacademy course, which comes up time to time. Now you have this plus compose subscription in Unacademy platform and also plus GS subscription. There was actually on 16, the price hike was due, but because of popular demand, it has been extended to 23. Only 2 days to go. What you are looking for, if you haven't subscribed, you kindly do so, take the benefit of the discount. Another very important point is, if you are taking 1 year and above subscription, you will get a 3 months extension. 3 months is a very long time. 3 into 30 means 90 days. It's a very good amount of time. Okay. Also, you see here, your prelims is just around the corner. It is only around 6 months. Your prelims is there 2022 in the month of June. Taking this into consideration, there is a new batch starting from tomorrow, that is 22nd of December, Mission 22, Lecture 2022. If in your roadmap you are planning to take up the exam in 2023, still that course is also there for 2 years, that is Mission 2023, Lecture 2023. Clear? Chalo. Nothing like preparing for your prelims through MCQ and also for revision of whatever you have studied through MCQ. Taking this into consideration, in Unacademy platform, we have test series. It is completely free of cost. The first one was Murnal's Monday. It started from yesterday, that is every Monday. So yesterday was Monday. Okay, response were very amazing. 20 MCQ in 20 minutes. It is available both in English and Hindi. Now, coming Monday also it will be there. Along with that, you have this T20 current affairs and Abhiyan. Current affairs deals with the news articles or important current development which is taking place. Abhiyan, that is the static part. of any of your subject, be it polity, geography, okay, economics, 15 MCQ, 15 minutes. It is also available both in English and Hindi. The only thing you need to keep in mind is the timing is different. For T20 current series, you have 7:30 p.m. from Monday to Friday. For this Abhiyan, the timing is 10 a.m. Monday to Friday. Okay, keep this in mind. You can use my enroll code, that is SUNEP10. Clear? Chalo. Let us go ahead with our discussion of today. Yesterday we have seen important material or materials that you will find in the ocean water. We have already seen major, minor. Okay, we have already seen the major and minor. Under the minor, okay, under the minor section, one was the gases like CO2, oxygen, nitrogen, which get dissolved. We have seen the percentage, we have seen the significance of this. The other type of minor material that you will find in the ocean water is this particular nutrients. Okay, see, I will give you, just for your benefit, let me go back and show you what we have studied yesterday. You see here, yesterday we have seen the material which is there in the seawater, or the characteristics of the seawater is, okay, seawater is, there are some material which is dissolved. There are some material which are suspended in the seawater. Now in the seawater, the dissolved material are broadly classified into two. One is the major constituent, the other is the minor constituent. The major constituent we have seen yesterday, those are chlorine, sodium, sulfate. Okay, now minor one we have seen, these are dissolved cases we have seen yesterday. Today we will see the nutrient and trace element. Yes, the minor constituent consists of only around 0.3%, but it is very, very important. Even if the absolute numerical data or numerical figure is only 0.3%, okay, it has got huge importance, highly important. Why? Because we have seen yesterday, if there is no dissolved case like oxygen, the marine organism will not survive. Therefore, if the minor constituents are not there, then there won't be any life which is possible in the marine environment. Therefore, even if it is only 0.3%, this minor constituent, it plays a very, very crucial role in the marine ecosystem. So under this minor constituent, yesterday we have seen this one dissolved case, the other is this nutrient. Let us go and see what is this particular nutrient. Clear? The nutrient which is there in the oceanic water or sea water, they are also known as the fertilizers of the ocean. Kindly remember it by alternative name. See, in your MCQ, there may be a question like nutrient of the or what is the fertilizers of the ocean. There will be 3-4 options. Nutrient will be one of your option, which is a correct answer. Okay, because see, UPSC has a habit of asking you questions from alternative name. Okay, that is a very important that is a very regular or general practice done by UPSC. Okay, so it is important to know about the alternative name. Now, under this particular nutrient, what are the different components? First is the inorganic part. Okay, inorganic part. The inorganic part consists of nitrogen, phosphorus, silica. Now, from where it is coming? It is usually coming, one of the sources, from the river runoff. The river discharges on the ocean. The river that is running over the terrestrial land takes this inorganic material to the ocean water. Okay. Second, nutrients are removed from water. These nutrients are removed from the water as the plant population grows, because the plant observes this. Okay, the plant takes this nutrient for its growth. Now, it will return as they die and decay. Now, the plant population will take up the nutrient. After some time, when the plant population dies down, it will decay, decompose, again it will return. So there is a cyclic process that is going on. So that is the inorganic part, which is the nutrient. Under this, you have this organic also, organic nutrient. They are usually the proteins, carbohydrates, lipids, vitamin, hormone. The green and yellow substance that you will find like this in the ocean ecosystem, they are known as clepstos. Kindly remember the term, it is very, very important. The green and yellow object that you will find in the ocean like this, it is known as clepstos. They also come under this organic. Let us go to the third, that is the traces. Under minor constituent, we have gases, we have nutrients, and the third one is the traces. Now you see all these elements, iron, iodine, all of this. Now, very, very important, kindly remember this. Why? Because especially in your prelims, in the multiple choice question, there may be a question regarding what are the following elements that are found in the seawater. In the option, they may give you all of this, okay, or any of this. Therefore, in traces quantity, in a very less amount of quantity, that's why they are also known as the traces element. These elements are also found in the seawater. Clear? Now, what is salinity? The amount of, this you see here. We have already seen regarding the major and minor constituent of the seawater. Okay, some are suspended, some are dissolved. Now we are talking about the dissolved part. Now you see here, the chlorine. See, major constituent occupies, just now we have seen, the major constituent consists of around 99.7%. Out of that, in the seawater, out of that, 55% somewhere it is chlorine itself. Therefore, the amount of chlorine which is present can also give a very good information about the salinity of that particular water. Okay, but the actual chlorinity is around 19.2. There is one constant, that is 1.8. So if you multiply, salinity is nothing but this constant into chlorinity. So if you add up, if you multiply this, it comes to somewhere around 34.5, which means it is the weight of an iron. It can be expressed in this. It can be expressed in grams per kg. It can be expressed parts per thousand. Okay. Now, there is one principle of constancy, Forstner's constancy. What is that principle? Say for example, it is my world ocean. You go to any place, you take a volume of water, you examine its salinity. Because of the nature of the ocean water, which is fluid in nature, because of well mixing of the water, because of ocean current, so on and so forth, circulation, the salinity of the ocean water as a whole is constant everywhere. Clear? Salinity of an ocean as a whole, it is constant. In general, we consider like that the salinity of the ocean water is such and such, and they are constant. Clear? In general. Okay. See, don't worry about the specific case. Specific case we will deal one by one. But in general, we consider that the salinity of the ocean is equal in all the region, and it is somewhere around 34.5, either grams per kilogram, parts per thousand, so on and so forth. Clear? But there are exceptions to this. Okay. When I say constancy, due to constancy, or which means, you see here, the principle of constancy is you take a volume of a water. Okay, I take a volume of a water and I see the percentage of the dissolved material here. Then the ratio of dissolved material like sodium, potassium, they will maintain a constant ratio. That is the meaning of constancy. Clear? Now, but there is an exception to that. The exception is in a region like hydrothermal plume region, or because of anthropogenic. Say for example, we have already discussed what is MOR, that is mid-oceanic rich region. Now in mid-oceanic rich region, the molten lava is coming out like this continuously. When a molten lava is coming out continuously, the molten lava has, okay, it comes, some gases comes out, some mineral comes out. Therefore, around this MOR region, the constancy may be disturbed. Means the ratio of composition of different dissolved material in the ocean water. Okay, like the chlorine is this much, potassium is this much, so on and so forth. That particular ratio of combination of this dissolved material may vary in this particular hydrothermal plume region. Hydrothermal plume, in a sense, it may be the MOR region or it may be a hotspot location. That is one. The other important point is anthropogenic, especially in the coastal region. If you are using certain chemical fertilizers in the agriculture, or it may be a industrial discharge or effluent, if it is released in the ocean water, that constancy may be disturbed. Clear? Now, variation of salinity. How salinity varies from one region to the other. Let us first see the horizontal distribution of this salinity. Okay, now you see salinity, if you go and see across the world, near the equatorial region, okay, the salinity as compared to the tropical region, there is more salinity in the tropical region around 20-degree latitude. Okay, from the equator around 20-degree north latitude, salinity is maximum. Why it is not maximum in the equatorial region? Why? Because you see here, salinity is what? Say for example, I have a water body. If temperature is high, water will evaporate. When the water evaporates, leaving behind the sediments in it or the dissolved material in it, then the salinity of this will increase, right? Now, so in a place where you have a maximum insolation, then maximum evaporation will take place. Also, the air over this particular region, the relative humidity, we all know, more the temperature, more the relative humidity. Means, more relative humidity means the air above the water can hold more moisture. Okay, now, increase in temperature increases the relative humidity also. Now, you see here, we all know that the sun, there is an apparent shifting of sun insolation, but it stays over the equatorial region. That we all know. Then why not more salinity in the equatorial region? Because in equatorial region more heat is there because of the sun's apparent position. Then why not in the equatorial region? The reason is very simple. In the equatorial region, yes, the sun insolation is there, but in equatorial region there is a cloud formation which is there. Therefore, the sun insolation is obstructed to some extent. But when you go away from the equatorial region, around 20-degree north latitude in the tropical region, the sky is clear. More insolation. More insolation results in higher precipitation. And when the precipitation, more insolation means higher evaporation. And even the relative humidity of the air over this is increased. Therefore, the air is also able to hold more moisture. Therefore, more evaporation. Therefore, leaving behind the sediments here, increasing the salinity of this area. Clear? Let me give you one scenario. When the air is very, very cold, okay, when the air is very much colder than the water, it can contain relatively less moisture. Why? Because relative humidity will be less and the condensation will take place. Such kind of condensation is known as sea smoke. Kindly keep this in mind. I have put this particular point here. Why? Because we are discussing about relative humidity. It is a very, very important phenomena, okay, and very, very important from your exam perspective also. Clear? Now, you see here, variation in the salinity can be because of the freezing also. How freezing affects salinity? You see here, suppose I have a water body here. Now, because of lower temperature, if there is a freezing which is happening, during freezing, the sediments are not getting frozen. It is only the water, the pure water which is getting freeze. Therefore, if a freezing is taking place, then the more water is getting frozen, leaving behind the sediments, thereby increasing the salinity of the water which is remaining here. That is how freezing affects the salinity. Precipitation. If there is more fresh water rainfall here, then the salinity will decrease. How evaporation, we have already seen. How this particular wind is affecting the salinity. You see here, say for example, I have a water body here. Okay, this is a water body. Evaporation is happening. Now, if it is the air above this water body is now saturated, say for example, relative humidity is 100%, say for example, it is completely saturated, then no more evaporation will take place. We have already established the relationship of evaporation and the salinity. But say for example, if there is a strong wind which is coming, then this particular air over this region is transferred to other place, bringing in more dry air to this location. Therefore, now evaporation will again continue, thereby increasing the salinity of this. Therefore, whether there is a wind in that particular location or not, that is also important. Clear? Now, let me give you one example about horizontal distribution of salinity, or horizontally how salinity, change in the salinity results in certain kind of water movement from one region to the other. Let me take the example of this Mediterranean Sea and Atlantic Ocean. You see here, you see here, come here, come to this part. Okay, now just forget about this diagram, you come to this part. Say for example, in this location I have a very high evaporation which is taking place. Now, because of high evaporation, there may be a, now number one, because of high evaporation, salinity of this region will increase. Increase in the salination or salinity results in the water becoming heavier, so it will come down. The other is, whenever lot of evaporation is taking place, there may be a slight depression which will be created like this. Okay, slight depression will be created in this manner because of heavy evaporation which is taking place from this particular region. Okay, two phenomena happening. Kindly observe. One is because of more evaporation. Okay, because of more evaporation, the water, remaining water here is becoming more saline, means very dense. Therefore, has a tendency of coming down. Second, because of more water getting evaporated, there may be a slight depression will be created. These two phenomena results in water in this region coming down, moving in this direction. In order to fill the vacuum or slight depression which is created here, under the influence of the gravity, this water from the surface will come towards this location. But below, deep down, the bottom transfer will be from this location to this location. The surface transfer will be from this location to this location. And why and how it will happen, I have already explained to you the two process. Evaporation happening rapidly, depression creating. Second, the remaining water which is here becoming more saline, more dense, coming down in this direction, and the cycle is set up. Now, this particular exact thing is happening in the transfer of water between the Atlantic Ocean and the Mediterranean Sea via the Strait of Gibraltar. The Mediterranean Sea region, because of its confinedness, evaporation, and also the latitude where it is, and also the high pressure cell in this, around this subtropical high pressure area, evaporation, clear sky, evaporation is happening rapidly like this. Because of this, there is a slight depression. Another point is the water in the Mediterranean area is very dense, very saline. Therefore, tendency of coming down in this manner. Therefore, on the bottom of this region, water is moving out from the Mediterranean region to the Atlantic Ocean like this, bottom current. But on the surface, the Atlantic Ocean water enters the Mediterranean Sea in this direction. And this mechanism continues. Clear? Now, let us go to the polar region again. let us go to the polar region. In polar region, see, just now we have seen the relationship between temperature, relative humidity and temperature, relative humidity, evaporation and salinity. We have seen whenever there is a higher temperature, more evaporation, even the relative humidity will increase, so the air can absorb more moisture, more evaporation, resulting in the remaining water to be very saline, which we have already seen the relationship. Now in the polar region it is very cold, so in the polar region the water should be less saline, right? Do you agree to that point? In the polar region the water should be less saline, right, as per the temperature. But you see, in the polar region salinity is again high. Why? What is the reason? In the polar region temperature is low but the salinity is high. Why? Freezing. Now the process of freezing will come into being. Freezing I have already explained to you. During the process of freezing, it is only the pure water which is getting frozen, leaving behind the sediments, thereby increasing the salinity of that particular region. Clear? Influence of river on the salinity of the ocean. A sea at the same latitude with or without the river will have different types of salinity. Why? Because if a ocean water is there, okay, sea water is there, when you have a river which is coming and debouncing or discharging in this region, what will happen? It is a fresh water. It will influence the salinity of this particular river, sea water in this particular location. Clear? High salinity in the northeast Atlantic due to Gulf Stream. You see here, Atlantic Ocean, northeast of Atlantic will be here. Now in this particular region salinity with respect to the latitude is much higher. What is the reason? We have an oceanic circulation like this, the Gulf Stream. Okay, now because of this oceanic circulation, it is carrying the saline water from the lower latitude, like from the tropical region that we have seen just now, to a higher latitude, thereby increasing or influencing the salinity of this particular region. Clear? Other important factor for the horizontal distribution of salinity is the size of opening, okay, connecting the sea and ocean. You see here, in the same latitude, okay, in the same latitude, a water body like, Red Sea, it has got a very small opening here connecting with the main water body here. Therefore, even if in the same latitude, if there is a water body which is having a very small opening, then this area the salinity will be much higher as compared to the water body, or you can say the sea water in the same latitude but in the open ocean. Therefore, the opening of the water body also determine. Why? Because see, it is less small opening means not so well circulation or mixing of the water which is taking place here. Therefore, it is as if it is confined. Yes, connection is there, but it is confined. Therefore, evaporation will be more, okay, resulting and less mixing as compared to the water body in the same latitude in the open ocean, thereby increasing the salinity of the water in this particular region. Clear? Now, let us quickly go and see the vertical distribution of this particular salinity. Okay, we have seen the horizontal distribution. Let us go and see the vertical distribution. In vertical distribution, there is no fixed rule as such. Therefore, it is important that you remember, in the higher latitude, salinity increases with depth. Therefore, in the higher latitude, like in the polar region, the moment I come down, I go from surface towards the bottom of the ocean, salinity keeps on increasing. That is one. In the middle latitude, it decreases up to 200 fathoms, and then if you go further down, it increases. In the equatorial region, first it will decrease, after some time again it will increase, and if you go further down, again it will decrease. There is no standard rule or no fixed rule in the vertical distribution of salinity. Okay, now let us come to the last point, that is the suspended material. Okay, see, kindly follow the structure we have seen. dissolved and suspended. Under the dissolved, we have seen the major constituent, minor constituent. Major constituent, minor constituent we have seen. Okay, and related to this we have seen the salinity. Now let us go and see the suspended material which is there in the seawater. The suspended material which is there in the seawater, they dissolve, okay. With time, they dissolve, they will gradually dissolve. Some will dissolve, some will add to the sediments of the ocean. Okay, the suspended material which is there in the ocean water, some will, if give sufficient amount of time, will gradually dissolve in the water itself, sea water, or some will add to the sediments of the ocean. Decomposed and return as nutrient for the plants, this particular suspended material. The solution of particles alters the chemical composition of ocean bottom water. Most abundant particle is the biogenous, this suspended material. Most abundant particle of this suspended material are biogenous. Biogenous is the shell and the fecal pellets of the organism, marine organism you can say. Clear? This suspended material is very low near the equatorial region. Why? Because in the equatorial region there is lot of marine organism, animal organism known by the name of this zooplankton. So the zooplankton is more. Why? Because in equatorial region it is having sufficient temperature, sufficient sun insolation. Okay, water temperature is also conducive. Therefore, marine organism will be more. And because of the presence of more marine organism near this equatorial region, the marine organism like zooplankton feeds on this suspended material. Therefore, it is low near the equatorial region. Clear? Next, density of the seawater. Okay, density of the seawater. It is either measured in gram per cubic centimeter. Okay, density is dependent on the temperature, salinity, and the pressure of that particular area. Now, let us see one very important phenomena. Okay, let us see one very important phenomena about density structure in the ocean. Okay, kindly follow the pointer. Very important topic. You see here. Kindly follow the pointer. Okay, you see here. This is equatorial region represented by 0 degree. This is equatorial region. This is southern hemisphere. This is northern hemisphere. This is a vertical depth. This is a sea level or the surface of the ocean. Okay, now it is observed the moment I go down near the equatorial region, okay, or near the equatorial region or in the lower latitude, the moment I go down, okay, the moment I go from the surface of the ocean towards the bottom of the ocean, I reach, see, one important point, keep this in mind. The moment I go down below from the surface of the ocean towards the bottom of the ocean, temperature will decrease, okay, will decrease. That is short, right? Why? Why? Because we are moving away from the source of the energy. Ultimately, for the ocean also, sun is the ultimate source of energy. So, the moment I go down, the temperature will reduce. Okay, that is fixed. But the rate of change or the rate of decrease of the temperature will vary from one region to the other. Now you see here, from the surface of the ocean to some depth, the decrease in the temperature is gradual. But it encounters the more I go down, it encounters a region where the change in the temperature, that is the rate of decrease of the temperature, is very rapid. Suddenly, very suddenly it changes. Say for example, if I'm going from the surface of the ocean towards the bottom, it changes, say for example, from 25 it comes to 23, 22, 21, like this in this region. There it encounters a region where the temperature drop is quite sudden. Say for example, from 21 it straight away come to 11. This numerical figure degree centigrade, these are just for illustration. I'm just giving you an example. Okay, now it will encounter in this particular area. Now the more I come down, again the rate of decrease in temperature is gradual. Now this particular region where there is a rapid change in the temperature gradient, or the rate of change of temperature, rate of decrease of temperature is quite rapid. It is known as thermocline layer. An abrupt temperature gradient, it is known as thermocline layer. If you go as per the density, it can also be known as pycnocline layer. What is the significance of this pycnocline layer or the thermocline layer? The significance of this layer is there is no easy mix between this upper water, that is the surface water, and the deep layer of the water. There is no easy mixing. Yes, since water is a fluid object, there will be some mixing. There will be some kind of mixing interaction among the water itself. But this particular pycnocline layer or thermocline layer, the significance is it does not allow easy mixing of the water from here to here. Now, we all know the oxygen is available at certain depth only, around 100 meters. Because the sun insolation is not able to go down right to the bottom of the ocean. It can only come down, it can only penetrate or diffuse up to a certain region, which is known as a photic zone. And there, the marine plant like diatoms make their own food by the process of photosynthesis we have seen yesterday. Okay, now oxygen is available, but deep down there is no oxygen then. But there is no oxygen from this side because no easy mixing. And for marine organism, it requires oxygen to survive. But you also find marine organism in this region. From where then? From where this oxygen comes, which makes marine organism to be present here. This oxygen or other nutrients or gases in the ocean bottom is usually supplied from the polar region like this. You see, this pycnocline layer is observed only near the equatorial region like this, or in the lower latitude like this. This pycnocline layer is not found in the higher latitude near the polar region. See, it is a sectional view, you can say. Sectional view about the ocean bottom. In the equatorial region, near the equatorial region or in the lower latitude, this pycnocline layer is present, but it is not present in the higher latitude. Therefore, from the higher latitude, as we have already mentioned, it is also a very high saline water because of the freezing which is taking place. Therefore, the density increases. When the density increases, it will come down. Downwelling will take place, so it will come down. During this process, it crosses the equator. You see here, near the surface or on the surface, transfer of water from one hemisphere to the other hemisphere is not so easy. But it is very, very efficient in the ocean bottom, where the transfer of the water crossing equator is very, very efficient. And by the process of this, high saline water, more dense water coming down, when the water is coming down like this, it is carrying nutrient, oxygen required and circulated here. So this is how circulation, oceanic circulation take place, especially the bottom ocean circulation. And that's why it allows for the presence of oxygen in this layer, which gives rise to the presence of marine organism. In climatology, we have seen the heat budget. Similarly, in the ocean ecosystem also, you have a heat budget. Very similar, very simple. You just have to know the terms. Okay, you see here. QS is the total amount of energy observed in the marine ecosystem. That is, absorption of radiation from the sun. That is QS. Now, it has to be balanced out in order to have this maintenance of this constant temperature. QB is nothing but the back radiation from the ocean itself. QN is nothing but the convection of sensible heat to the atmosphere. QE is nothing but the evaporation and latent heat. During our discussion of climatology, we have already seen latent heat for n number of times. That's why I'm not explaining here. Okay, released by condensation to the atmosphere. Whereas QU is amount of the heat used locally for changing the temperature of the seawater. And this is how the incoming solar radiation or the energy from the sun is dissipated or distributed in this manner, finally resulting into this. And this is nothing but the heat budget. Clear? Tomorrow we will continue with the temperature distribution in the ocean. Today we have seen the salinity distribution, vertically as well as horizontally. Tomorrow we will continue with the temperature distribution. This also we will see vertically and horizontally tomorrow. Okay, we'll end the session here today. We will continue tomorrow. Clear? Thank you so much for your patience and cooperation. We will meet again tomorrow. Bye bye and take care.